Now let's talk about flatness tolerances. Okay, so far we in form tolerances we just talked about straightness, and really straightness helps us set up everything else. Um, and flatness is kind of like straightness, but it applies over an entire surface where um, straightness just covers line elements. This would be the entire surface. Specifies allowable form variation for flat surfaces and derived median planes of parallel flat surfaces. It's only needed if the surface form needs a greater level of control than as required by the limits of size. No material condition modifiers are applicable when applied to a surface. RFS defaults when applied to regular features of size, and no datum feature reference is ever required. Um, Here's how we would apply it to a model. It's just a little dot with the flatness tolerance, da, 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 and it applies to the whole surface. No, there's no directionality associated with it. Um, it includes a flatness tolerance and a tolerance value. It's attached with a leader. It's on the same annotation plane. Now, if you're going to do this in the orthographic view, it looks something like this, where you take the extension line and apply the flatness tolerance to it, or you can do it with a leader. Okay, um, and you put that in a view where the surface appears as an edge. Okay, that's always how you do that. Attached to an extension line, leader terminating with an arrowhead, or the leader terminating with a dot if it's on a surface rather than an edge view. So one or the other. Okay, so here's what that means. Okay, so flatness tolerance zone on a surface. It's really going to give you a tolerance zone that's bounded by two parallel planes extended in all directions without any fixed orientations. No additional tolerances based on feature size if it's RFS. Okay, so here's what we got here. Our part is over here. It's 505, 500 plus or minus 5 thousandths with a 3 thousandths flatness tolerance. Here's how you would look at that. 505 is our maximum size. If we look at any of these line elements here, then it would have to only vary by 3 thousandths. Okay. Notice that the 3 thousandths parallel planes are set up by the mins and the maxes of our actual part and not by this 505. Okay. So that's how it's interpreted. How is it checked? You'd probably use like a surface flatness with a height gauge. Here we've got a granite plate. Here's our part right here. Here's a dial indicator with the height gauge. We would move this indicator all over all elements of the surface, both in this direction and in this direction, and make sure that our total indicator movement doesn't exceed our size, our flatness tolerance. So again, it's not dependent on the size, it's dependent on where our surface elements is. So that's why we're saying it has to be, see, this is where our surface elements are. That's what dictates our two parallel planes, and not necessarily by the maximum size. Here's another way to do that. You would have an indicator sticking through a flat plate, and then you would move the workpiece over top of this indicator in all directions. That's how you would check it. So in this case, what would happen if we applied that tolerance to a derived median plane? Okay. Yeah, so here we have a feature of size, and we have it applied, this flatness tolerance applied to that plane. What does that mean? We have 3 thousandths parallel planes at RFS. That is our tolerance zone. It's two parallel planes, and then at 620 min and the 630 max. So that is what that means. So how would you verify that? Flatness tolerances applied to a regular feature size assumed to apply at RFS unless otherwise shown. Opposed point measurements made and derived median plane location is calculated at RFS. And then we would take something like this where we have a gauge here made to the virtual condition, and then we would slide our part through there to make sure that it all fit. So that's how we would verify flatness of a derived median plane. I want to talk a little bit about flatness versus straightness. There's a lot of analogies that go on with flatness and straightness. I mean, you'll see analogies pop up. One of them has to do with circularity tolerances. Our last two form tolerances we're going to talk about are circularity and cylindricity. And so circularity tolerance establishes an acceptable circular surface element variation relative to a perfect circle and creates a boundary of two concentric circles. It's established an allowable variation of each individual circular element on any feature with a circular cross-section. That could be cylinders, cones, and spheres. Circular cross-sections exist where all points are equidistant from an axis or a center point. Sometimes they call this roundness, but it's really not roundness. So let's look at how to apply that. If you're applying it in the model, it's done with a surface dot, a leader, the size and the size tolerance, and then finally the form tolerances, which is the circularity. If you're applying it to a feature in an orthographic view like this, you would have your feature size here, and then you can point to it with a leader and apply it that way. How is this interpreted? Okay, so circularity tolerance applied when variations smaller than those permitted by the size tolerance. Again, you only need these form tolerances if you need better controls than what you get with your size tolerances. So what we have here is 875 plus or minus 10 with 5 thousandths circularity. So here's our subscribe circle at 885. That is our maximum material condition plus, that's our maximum material condition. And then over here we have our internal. This is our tolerance zone here, the 5 thousandths, and that's our form tolerance. Okay, so we have our max and we have our min, and then we have our form tolerance within that zone. So its circularity tolerance value is the radial distance between the inner and outer boundary circles. So that's what that means for circularity. Here is a circularity tolerance applicable to cylindrical surfaces, a shaft or a hole. Cylindrical surfaces exist when pole points are equal distance from an axis. Feature control frame includes the geometric characteristic, the tolerance value, no diameter symbol for these, no diameter symbol for these at all, and the tolerance zone by two concentric cylinders, radial separated by the tolerance value. So let's talk about cylindricity, mind you. Okay, now if circularity, the tolerance zone was two concentric circles, cylindricity, the tolerance zone is two concentric cylinders. Okay, so really what you're doing is you're applying a circularity tolerance across the entire length of your part. Okay, so it's kind of like, you know, the difference between a straightness tolerance and a flatness tolerance. So a straightness tolerance on a surface checked surface elements in just one direction, in just one line. But then flatness tolerances cover the entire surface in both directions. Okay, so it's kind of like an extension. Flatness is kind of like an extension, if you will, of the straightness tolerance. And then, kind of like you're talking the difference between circularity, which covers just one circular element in your part, whereas cylindricity covers all of the circular elements when you're in your part considered all together. In which case, cylindricity is to circularity kind of like what flatness is to straightness. Okay, so there's a little bit of analogy there between, straightness to flatness, and between circularity to cylindricity. Okay, and this is how you interpret that. Okay, so you have over here the 1.135 max, that's your maximum material condition, and then once you have that, you have a 7 thousandths radial separation somewhere between these two concentric cylinders. Um, The cylindricity is established from size tolerances. So the cylinder diameter dimension established the MMC perfect form, and then the cylindricity variation is permitted by departure from MMC. Okay, so that's what we're talking about here. This is our MMC perfect form boundary, and the cylindricity allows us to vary from that. Okay, that concludes this movie. Thank you.